Good morning, girls. Let us continue with our previous topic, that is architecture of Oracle, right? In the last session, we learnt about the architecture of Oracle, Oracle database, right? And we had gone through some internal files like control file, log file, redo log file, data files, archive log files, and we cleared the concept of logical database structure and some terms related to logical database. They are table space, extent, data blocks, and segments. Today we are going to start with the instance architecture. Both are different thing, right? Whatever instance we create, that is called instance, means whatever database you are creating, that is whenever you start your Oracle, that means you are starting your instance, right? Now let us see the architecture of that instance. Every running Oracle database is associated with an Oracle instance. When a database is started on a database server, Oracle allocates a memory area called the System Global Area, SGA. See, one thing you have to remember is that this chapter having a lot of abbreviation in it, અને એ abbreviations theory ની અંદર frequently પૂછાય છે, રાઈટ? એટલે એક સાથે એક પેજમાં નોટ કરી લેજો બધા જ જે એબ્રિવિએશન્સ આપેલા છે અહીંયા એના ફૂલ ફોર્મ સાથે નોટ ડાઉન કરી લેજો. ફર્સ્ટ વન ઇઝ SGA, System Global Area. What does it mean? When a database is started on a database server, Oracle allocates a memory. જ્યારે પણ તમે ડેટાબેઝ સ્ટાર્ટ કરો છો, એટલે કે ઓરેકલમાં લોગિન થાઓ છો, ત્યારે ડેટાબેઝ સર્વર છે એ ઓરેકલની અંદર એક મેમરી એરિયા અલોકેટ કરે છે. That area is known as System Global Area and starts one or more Oracle processes which are required to open your database. This combination of the SGA and the Oracle processes is called an Oracle instance. આપણે જે memory area ની વાત કરી, which opens with the opening of our database, and the related process also starts, both jointly known as Oracle instance. The memory and the processes of an instance manage the associated database data effectively and serve the one or multiple users of the database. Here you can see the diagram of Oracle instance. Here you can see the area which is known as System Global Area, which is allocated by database server, right? It is called a memory area for running our processes for a particular database, as well as you can see the Oracle processes. So let us begin with the processes related with the instance architecture. What is the meaning of process that we are going to learn here? A process is a mechanism in an operating system that can run a series of steps, right? Whatever steps are required for running our database or running these processes, that is done with the help of operating system, right? Some operating system use the term job or task. A process normally has its own private memory area in which it runs. Multiple process Oracle system. Multiple process Oracle, also called a multi-user Oracle. This uses several processes to run different part of the Oracle code and additional processes for the user. Either one process for each connected user or one or more processes shared by the multiple user. I repeat, either one process for each connected user, જેટલા પણ યુઝર કનેક્ટેડ છે એ બધા માટે એક પ્રોસેસ, और એનાથી ઊંધું મલ્ટિપલ યુઝર્સ કે જે એક પ્રોસેસને શેર કરી શકે છે. Most database systems are multi-user because one of the primary benefit, or we can say advantage, of a database is managing data needed by multiple user at the same time. See, multiple database system no જે પર્પસ છે એ ક્યારે સોલ્વ થાય જ્યારે ડેટાબેઝ છે સેન્ટ્રલાઇઝ હોય, રાઈટ. એટલે કે ડેટાબેઝ સિસ્ટમ છે મલ્ટી યુઝર ડેટાબેઝ સિસ્ટમ હોય. એનો મેઇન એડવાન્ટેજ એ જ છે કે ડેટાબેઝને આપણે મલ્ટિપલ પ્લેસીસથી મેનેજ કરી શકીએ સેમ ટાઈમ પર અને મલ્ટિપલ યુઝર્સ થ્રુ. Each process in an Oracle instance perform a specific job. By dividing the work of Oracle and database application into several processes, multiple users and application can connect to a single database instance simultaneously while the system maintain excellent performance. Performance wise આપણે જોઈએ તો excellent performance ક્યારે આવે જ્યારે આપણું ઇન્સ્ટન્સ છે ઓરેકલનું જે ઇન્સ્ટન્સ છે એ સાયમલ્ટેનિયસ વેમાં પ્રોપરલી વર્ક કરતું હોય, રાઈટ. એન્ડ દેટ ઇઝ ઓનલી પોસિબલ વિથ ધ હેલ્પ ઓફ ડિફરન્ટ પ્રોસેસીસ એક્ઝિક્યુટ થ્રુ ધી ઓરેકલ instance or Oracle architecture, that too in multiple user environment. Let us see some of the process required for Oracle. Here you can see the types of processes are shown. The processes in an Oracle system can be categorized into two major categories. Number one is user process, run the application or Oracle tool code, and second is Oracle processes, run the Oracle database server code. Here server code include server processes and background processes. The process structure varies for different Oracle configuration depending on the operating system and the choice of Oracle options. See, અહીંયા ઓરેકલ જે છે એના અલગ અલગ કન્ફિગરેશન જે છે અલગ અલગ કન્ફિગરેશન એ તમારા જે સિસ્ટમ છે એની અંદર જે ઓપરેટિંગ સિસ્ટમ ઇન્સ્ટોલ થયેલી છે એના ઉપર ડિપેન્ડ હોય છે. એઝ વેલ એઝ ઓરેકલનું ક્યુ ઓપ્શન તમે ચૂઝ કરો છો એના પર પણ એ વેરી થાય છે, એટલે કે બદલાય છે. પ્રોસેસનું સ્ટ્રક્ચર છે એ બધા જ ઓરેકલ કન્ફિગરેશન માટે સેમ હોતું નથી. Here figure illustrate a dedicated server configuration. Each connected user has a separate user process. આપણે assume કરીને ચાલીએ છીએ that each connected user has its own, his or her own separate user process and several background process run through the Oracle. In the center you can see system global area is there, and that is shared by all the user as well as shared by the different processes of Oracle. This is called these processes are called background processes. In this section we are going to describe the two types of processes that run the Oracle database server code. Server process. Oracle creates a server process to handle the request of user processes connected to the instance. In some situation when the application and Oracle operate on the same computer, it is possible to combine the user process and corresponding server process into a single process to reduce a system overhead. What is the meaning of system overhead? How to reduce the system overhead? Let us clear the meaning of system overhead. System overhead એટલે આપણે એનું સિનોનિમ યુઝ કરી શકીએ બર્ડન ઓફ સિસ્ટમ. મીન્સ જે વધારાનું જે ટાસ્ક આવે છે સિસ્ટમ ઉપર, વધારાનો જે લોડ આવે છે, દેટ ઇઝ કોલ્ડ સિસ્ટમ ઓવરહેડ, રાઈટ. It is possible to combine the user processes and corresponding server processes into single process to reduce the system overhead. જો આ ઓવરહેડ આ બર્ડન છે એને ઓછું કરવું હોય તો સિમિલર ટાઈપના જોબ્સ છે, સિમિલર ટાઈપના જે પ્રોસેસ છે એક કરતાં વધારે યુઝર માટેના એને એક સિંગલ પ્રોસેસમાં કન્વર્ટ કરી શકાય, રાઈટ? સો ઇન this way we can reduce system overhead. However, when the application and Oracle operate on different computers, a user process always communicate with the Oracle through a separate server process. Server processes created on behalf of each user's application can perform one or more of the following operations listed here. Number one is run SQL statements issued through the application, read necessary data blocks from data files on disk into the shared database buffers of the SGA if the blocks are not already present in the SGA. I repeat, read necessary data blocks from data files on disk into the shared database buffers of the SGA, and if the blocks are not already present in the SGA, okay, ડેટા ફાઇલ્સની અંદરથી ડેટા બ્લોક્સને રીડ કરવા અને શેર્ડ જે એરિયા છે ડેટાબેઝ બફર છે SGA એની અંદર એને કોમન એરિયામાં પ્લેસ કરવા. Return results in such a way that the application can process the information. Userની as per the demand of user, it returns the result in such a way that application can process that information. Background processes. To maximize the performance and accommodate many users, a multi-process Oracle system uses some additional Oracle processes called background processes. આ જે છે એ બીજી ટાઈપ છે બેકગ્રાઉન્ડ પ્રોસેસ જે બેકગ્રાઉન્ડમાં રન થાય છે જેનાથી યુઝર અવેર નથી હોતું. The main purpose of this process is to maximize the performance and to accommodate more and more users in multiple user environment. This process is run in a background of Oracle. An Oracle instance can have many background processes. Not all are always present. There are numerous background processes run at a time, maybe some not run, and maybe some of this process run at the same time. The background processes in an Oracle instance can include following background processes: database writer process, DBWN, log writer process, LGWR, checkpoint process, CKPT, system monitor process, SMON, process monitor process, PMON, recoverer process, RECO, job queue process, archiver process, queue monitor process, and some other background processes. On many operating systems, background processes are created automatically when an instance is started. Yes, it automatically creates this process when an instance is started. An Oracle database consists of one or more logical storage unit called table spaces. As we have already discussed about the meaning of table space, right, which collectively store all of databases data. Each table space in an Oracle database consists of one or more files called data files, which are physical structure that conform to the operating system in which Oracle is running. Let us begin. DBWN, the database writer process. Write the content of buffer to the data file. Whatever changes done by the user of a particular database that do not immediately write into data files, but it stores in some buffer area, right? DBWN process writes this content of buffer to the data files. The DBWN process are responsible for writing modified buffers in the database buffer cache to disk. Although one database writer process is adequate for most systems, you can configure additional process DBWN through DBW9 and DBWA through DBWJ to improve write performance if your system modifies data heavily. Means user can create a DBW process by its own, right? It has only one default DBW process with number DBW0. This one process is more than enough, or we can say it is adequate for writing everything in data files. But if we want to configure some more processes, then we can create it. The purpose of creating more processes is to modify the performance or improve the performance of Oracle structure, right? If your system always modifies data heavily. Next process is log writer process, LGWR. The log writer process is responsible for redo log buffer management writing. The log buffer management, writing the redo log buffer to a redo log file on disk. LGWR writes all redo entries that have been copied into the buffer since the last time it wrote. LGWR normally writes fast enough to ensure that space is always available in the buffer for new entries, even when access to the redo log is heavy. LGW process જે છે એ redo log buffer management માટે work કરે છે, right? LGWR always redo ની જે entries છે એને multiple copies છે generate કરે છે, as well as એની અંદર જે last time જેટલું complete work થયું હતું એના આગળનો task છે એ redo log ફાઇલમાં એન્ટ્રી કરે છે. LGWR આ જે પ્રોસેસ છે એ ટ્રેક મેન્ટેન કરે છે કે ઓલવેઝ નવી એન્ટ્રીઝ માટે બફર સ્પેસ અવેલેબલ હોય. LGWR writes one continuous portion of the buffer to the disk. A commit record when a user process commits a transaction. Redo log buffers every 3 seconds when the redo log buffer is 1/3 full. When a DBWN process writes modified buffer to the disk if necessary. Checkpoint process, CKPT. When a checkpoint occurs, Oracle must update the headers of all data files to record the detail of the checkpoint. It is related to the header of data file, means the address or which data you are going to store in this data file, that all things, right, that all things reside in a header part of your data file. This is done by CKPT process. Next is SMON, system monitor process. The system monitor process perform recovery if necessary. At instance startup, SMON is also responsible for cleaning up temporary segments that are no longer in use. SMON is responsible for cleaning the memory, which is called temporary segments, right, that are no longer in use, and SMON process remove the data which are stored in this area. And for coalescing continuous free extent within dictionary managed table space. If any terminated transaction were skipped during instance recovery because of file read or offline errors, SMON recovers them. SMON has more than one task, right? Whatever terminated transaction were skipped during instance recovery because of file read or offline errors, SMON recovers them when the table space or file is brought back online. Okay. SMON checks regularly to see whether it is needed. Other processes can call SMON if they detect a need for it. This process is frequently asked in your theory exam. Next is PMON, process monitor process. The process monitor PMON perform a process recovery when a user process fails. PMON is responsible for cleaning up the database buffer and freeing resources that the user process was using. For example, it reset the status of the active transaction table, releases the lock, and remove the process ID from the list of active processes. Next is recover process, RECO. The recover process is a background process used with the distributed database configuration that automatically resolve failure involving distributed transaction. The RECO process automatically connects to the other database involved in transaction. When the RECO process re-establishes a connection between involved database server, it automatically resolves all in-doubt transactions, removing from each database pending transaction table any rows that correspond to the resolved in-doubt transactions. If the RECO process fails to connect with a remote server, RECO automatically tries to connect again after a time interval. Next is job queue processes. Job queue processes are used for batch processing. They run user jobs which are in queue. They can be viewed as a scheduler service that can be used to schedule jobs as PL/SQL statements or procedure on an Oracle instance. Given a start date and an interval, the job queue processes try to run the job at the next occurrence of the interval. Dynamic job queue processes can run a large number of jobs concurrently at a given interval. The job queue process run user jobs as they are assigned to them. Archiver process, ARCN. Here the meaning of N means number of archiver processes. Okay. The archiver process copies redo log files to a designated storage device after a log switch has occurred. See, it creates the replica of redo log files. RCN processes are present only when the database is in archive log mode and automatic archiving is enabled. Next process is queue monitor process, QMN. The queue monitor process is an optional background process for Oracle Streams Advanced Queuing, which monitors the message queues. You can configure up to 10 queue monitor processes. Okay, so these are the processes related to instance architecture. Now, introduction to Oracle database memory structure. When an instance is started, Oracle database allocates a memory area and starts background processes, which we have discussed recently. The memory area stores information such as program code, information about each connected session, even if it is not currently active, right? Means inactive. Information needed during program execution, for example, the current state of a query, from which row are being fetched, Then information such as log data that is shared and communicated among processes, cache data such as data blocks and redo records that also exist on disk. So this type of information are stored in memory area. Memory architecture overview. The basic memory structure associated with Oracle database includes System Global Area (SGA) and Program Global Area. The SGA is a group of shared memory structure, as we have already discussed in our last session, right, known as SGA components that contain a data and control information for one Oracle database instance. The SGA is shared by all server and background processes. Example of data stored in the SGA include cache data blocks and shared SQL areas. Whereas PGA, Program Global Area, a PGA is memory region that contain data and control information for a server process. Actual data reside here for temporary purpose, right? It is non-shared memory created by Oracle database when a server process is started. Access to the PGA is exclusive to the server process. There is one PGA for each server process. Background process is also allocated there on PGAs. You can see the diagram of Oracle database memory structure. As you can see, the central area is known as System Global Area, where you can see the common memory pool, Java pool, buffer cache, redo buffer, shared pool, stream pool, large pool, and other component. And some processes are interacting with each other through this memory area, and each process is having its own PGA, right? Means Program Global Area. SGA is used to store database information that is shared by database process. It contains data and control information for the Oracle server. SGA consists of several memory structure. Redo buffer. The redo buffer is where data that needs to be written on the online redo logs will be cached temporarily before it is returned to disk. Okay, since a memory to memory transfer is much faster than memory to disk transfer, use of the redo log buffer can speed up database operations. The data will not reside in the redo buffer for very long time. In fact, LGWR log writer initiates a flush of this area in one of the following scenario: every 3 seconds, whenever someone commits, or when LGWR is asked to switch log files, when the redo log buffer gets 1/3 full or contains 1 MB of cache redo log data. Second is buffer cache. The block buffer cache is where Oracle stores database blocks before writing them to the disk and after reading them in from disk. Shared pool, another memory area. The shared pool is where Oracle caches may beats program data. When we parse a query, the parse representation is cached there. Before we go through the job of parsing an entry query, Oracle searches the shared pool to see if the work has already been done. VLSQL code that you run is cached in the shared pool, so the next time you run it, Oracle does not have to read it from the disk again. So it saves the time of a transaction, right? Transit time it saves. Next is large pool. The large pool is an optional memory area. It provides an area for Oracle backup and restore utilities. Java pool. The Java pool is RAM region within the Oracle SGA, and the Java pool RAM is used to provide parsing of Java code and scripts. Installation task related to Java application with Oracle. Stream pool. The stream pool is used to buffer a queue messages used by the streams process as it moves or copies data from one database to another. So this is all about the memory structure of Oracle, right? uh, See you in the next session with new topic, that is creating and altering database. Thank you.